Continuing on, this is grade 8, benchmark 1 test. This is page 2, which will be the continuing on from the problems that we did 1 through 7. Here we're going to do 8 through 11. So continuing on with rotations and objects, it says line N and line G are parallel. So we have two lines that are parallel. Both lines are rotated 90 degrees around about the origin. Are the image of the lines parallel? Yeah, they're still going to be parallel even if we rotate them around, and it doesn't matter if it's here. If we rotate it 90 degrees, if we rotate this, and if we take those points and 90 degrees is going to be there, and you take another parallel line, even over here, and you rotate that 90 degrees, it's still going to be parallel. So you notice that the lines are still parallel. And so that would be, yes, they are still parallel. And we could take points and apply that 90-degree rotation and connect them and still see it in that manner if you want more specifics. You translate a line 8 units left. Is the image of the line still a line? Yes, translating it. So we'll take a line. We'll translate it 8 units to the left. So we'll take, and we can take the points. Here's the point. We'll take a point here, we'll take a point here. And if we translate it, if we move it, let's group those together. So group. If we translate it 8 units to the left, it's still a line. Yes, still a line. Yep, good question. Number 10, the vertices of a triangle are -2, -1. This is A. B is 2, 2. And C is -1, 1. Whoa, that's not a fun triangle either. They've given us a couple kooky triangles. And if we dilate the triangle using a scale factor of 2, what are the coordinates of the image? So when we scale factor, when we scale it to 2, we're extending or expanding the object 2 units. So, and this will be a little bit easier now that we're very comfortable with this template that I showed you. For every xy, it's going to be equal to 2x 2y. So we can take each of the values, -2, -1, and we can plug that into this. And so we get 2 times -2, comma 2 times -1. So this is point A. So A prime is going to be -4, -2. So we can do that. Let's do -4, 1, 2, 3, 4, 1, 2. That's going to be A prime. And point B was 2, 2. We put it into the template, 2 times 2, 2 times 2. So my B prime is going to be 4, 4. So if we draw that, 1, 2, 3, 4, 1, 2, 3, 4. Here's B prime. And then C, that coordinate is -1, 1. If we put it into the template, we get 2 times -1 and 2 times 1, and making C prime -2, 2. And let's draw that. -2, 1, 2. 1, 2, that's a bad place for the original C. Let's move you a little bit. Original C. And let's make 1, 2, 1, 2. So this is C prime. And there is our object. So if we draw that, that object now has been dilated 2 times. Okay? So those are the points, those are the coordinates for the dilated object. Dilations, translations, reflections. Very, very important. Describe the sequence of rigid motions between the triangles. If we take the lighter of the two triangles and we reflect it over the y-axis, that'll take us to this. What is it? It's 3 away. So boom, boom, boom would be our reflected object if we reflect it over y. And then if we shift it down 1, 2, 3, if we translate it down 3, we would get it. So reflect over y-axis, and then translate down 3 would get us our new object. Good. Describe the similarity transformation between the triangles. Describe the similarity transformation between the triangles. Well, okay, so let's do translate. Ooh, maybe that's a dilation. No, we're going to translate it left 1. That gets it here. And then, translate it 1 there. Translate left 1 and down. Let's do left 1 and down 1. So that gets it to here, and then we're going to dilate it. Dilate. So it gets it here and here. So my new object is here. This is my new after the translation. Sorry. I like that. That gets it there. And then we're going to dilate it 1/2. I'm going to dilate it 1/2. So every point we will take, we will dilate it. No, that's not 1/2, because 1/2 of 3 would be 1 1/2. How do we dilate that? Well, dilating, and then we have to reflect it. We still have to reflect it over the x-axis too. What's going to get that 1 to 1? How does 3 become 2? Oh, we're going to multiply it by 2/3. Sorry. Yeah, but that gets 2/3. How does that? It's interesting how they do that. I'm going to have to look at this one. This one's a quirky one. I don't know this one. Let's look at number 12. What does 12 say? Oh, it is 1/2. So dilate the lighter triangle with respect to the origin scale factor of 1/2, and then reflect the image in the x-axis. Okay. No, I was there. Dilate it 1/2 was correct. So 1/2 gets it to 2. So maybe instead of translating, that's what it was. So I messed up in the translations. Let's delete these. So let's erase the translating. Let's dilate it first, and let's see what we get. So 1/2 gets us to 2. Oh, yeah. So 2, 1. Well, that's not the right color. Yes, I like this. This definitely works. So the point is 4, 2. Dilating it 1/2 gets us to 2, 1. 2, 1. And this point is 2, 2, which gets us to the point 1, 1. Which, yes, okay. And then this last point is 4, 2. No, not 4, 2. That was 2, 4, sorry. 2, 4. 2, 4 gets us to 1, 2. And this is 4, 2, gets us to 2, 1. And 2, 1 is here. Yep, and now we reflect it over. So dilate and then reflect over X. All right, good. Now, see, we can always learn, and we can, just review, and it's okay. If you don't know this, it's an opportunity for you to learn something new and to add it to your knowledge base.